All right. So, last thing we did was rectangular approximation for the three types of rectangular approximations: LRAM, RRAM, MRAM. Okay. And we found area under the curve from 1 to 3 for each of those. And you can see that even though it's area for the same region, they're different, right? LRAM's a little low, RRAM's a little high, MRAM's kind of in the middle. They're approximation methods, right? So the area is probably going to be somewhere around 4 to 5, probably the true area, okay? But we do the best we can with approximation methods, okay? Okay, so next one, number 5. Number 5. So this one is different than a graph. They give us a table, but I could graph them, right? It's the same idea. It's the same idea. If you wanted to draw a graph, you could. You don't need to draw a graph. You can just use the values because they give you the x and the y values. Okay. So using the table, we have to find MRAM. Okay. Midpoint for 0 to 8. So the bounds starts at 0, goes to 8, and we have to use 4 subintervals. Okay. So that means 4 rectangles. We have to have 4 rectangles. That's what that means. Okay. Let's see. 4 rectangles. Now it doesn't say that the rectangles have to be the same width. It doesn't say that the rectangles all have to be the same width. They can be, but it doesn't necessarily say that they're not, that they have to be. Okay, so again, it's a table. It could look like a graph. We could make it look like a graph. If you wanted to, you could graph it, but you don't necessarily need to. If you're a more visual person, create a graph from 0 to 8, plot points, connect the dots, do it that way. Okay? But the easier way to do it is just to do it using the table. Okay? So we go from 0 to 8. Right? 0 to 8. That's our total interval from 0 to 8. And we have to have 4 subintervals. So it makes sense to have how wide each rectangle, how wide does it make sense to? 2. It makes sense. Does it need to be 2? No. But it just makes sense that I need to go, the interval's 8 units wide. I need 4 rectangles. It just makes sense that each rectangle is going to be 2 units. Okay? And I need MRAM. So what I'm going to do is I'm going to draw, so I'm going to have a rectangle that goes from 0 to 2 wide. 0 to 2 wide. So it's 2 units wide. And then I'm going to have a rectangle that goes from 2 to 4. And then I'm going to have a rectangle that goes from 4 to 6. And then the final rectangle is going to go from 6 to 8. Okay? So now what I need to do is figure out the area of each of those rectangles. Okay? So the first rectangle, I'll highlight that in yellow. How wide is that first rectangle? 2, right? How tall is it going to be? How tall is it going to be? The height? No. How tall is that first rectangle going to be? So this is MRAM, right? So let's go back to our example of MRAM. What determined the height of each of those rectangles? The midpoint, right? In between. So if the first rectangle went from 1 to 1.5, right? The middle determined the height, right? So let's go back to this rectangle. The first rectangle goes from 0 to 2. What's the midpoint of that? 1. How tall is 1? 20. So that's going to determine the height for this guy. Okay? That's going to determine the height. 20, because 1 is the midpoint. How tall is the y value at 1? 20. Okay? Second one goes from 2 to 4. Width of 2. How tall is the second rectangle? It's going to be 14 because the midpoint is 3 and 3 is 14 high. That's the y. Y goes up. Again, if this is like, if you need a visual picture, draw a visual picture. You could easily make a graph. You can go 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 5, 10, 15, 20, 25. Zero, 21. 1, 20. 2, 15. 3, 14. 4, 13. 5, 12. 6, 11. 7, 5. 8, 3. Oops. That's a sketch. This is just a sketch. And draw rectangles visually. Our first rectangle is going to be from here to here, and it's going to go up to here. That's our first rectangle. The second rectangle is determined by the height of the middle, the midpoint, right? The third rectangle, 5 is going to determine the height. Well, the height at 5 is 12. And then the last rectangle, the height of the last rectangle is going to be determined by the y value at 7. The y value at 7 is 5. Two times, oh yeah, sorry, yep, it should be, change that 5 to a 2. Thank you. Okay. So if you need a visual, draw a visual. Take a 5 to 10 seconds to draw something. But if you don't need it, you don't have to, it's up to you. Whatever makes sense to you. Okay. So let's see, we got 40 plus 28 plus 24 plus 10, 68 plus 34, we got 102. So MRAM from 0 to 8 is 102. Okay. Using the table. So let's use this same table. What if it was LRAM? What if it was LRAM? How tall would be the first rectangle be? Would it still be 20 or would it be different? 21, yeah. The first rectangle would be 21 because that's determined by the left side, right? The next rectangle would be 15 high, the next rectangle would be 13 high, and the next rectangle would be 11 high, right? RRAM, the first rectangle would be 15 high, The second rectangle would be 13 high, 11 high, 13, and 3 high. They'd all be the same width. Width wouldn't change, but the heights would change because it's a different type of approximation. Okay? All right, so let's go to number 6 now. Number 6 is LRAM now. So now this is LRAM. We got to go from 2 to 12. 2 to 12. Okay. So the interval is 10 wide. This time we need 3 intervals, subintervals. But they only give us certain values. They don't give us every value in between 2 and 12, every whole number. They don't give us 2, 3, 4, 5, 6. They only give us 2, 6, 10, and 12. So we can only use what they've given us. And they don't give us an equation. They didn't say f of x equals, so we don't have an equation to plug into. So we're going to do what we got. So I need 3, right? So the first one's going to go from 2 to 6. The next one's going to go from 6 to 10, and then the last one's going to go from 10 to 12. That's the best I could do with the table they've given me. Okay? If they gave me more values, I could do it differently, but I need 3 rectangles, and they've only given me 4 values. 4 x values, 4 x and y values. Okay? So the area from 2 to 12 for f of x, this is LRAM. So the first rectangle, how wide is the first rectangle going to be? 4, right? It goes from 2 to 6. 2 to 6. That's the width. X is the width. So from 2 to 6, the area or the length is 4. That's the width. Now the height. How do I determine height for LRAM? What do I look at? The left point, right? This guy here, the left side. The left side is right here. The height is at 21. So that means this rectangle is going to be 21 tall. Again, this one, if you draw a picture, if you need to see visually, you need to see the rectangles visually, draw a picture. That's that first rectangle done. The second rectangle goes from 6 to 10. That's also 4. The left side is 6. The y value is 4. So that means it's going to be 4 high. The last rectangle is going to be not as wide. It's only going to be from 10 to 12, so that's 2. The left side at 10 is going to be 3 tall. Okay, so the first rectangle is 4 by 21. That's 84 area. The second rectangle is 4 by 4. The last rectangle is 2 by 3. Add them all up, and what do you get? What is that, 106? 106 units. Units squared, technically, but... Okay. All right. Yeah, 2 more. Last 2. Number 7, they didn't give us a table. There is no table. But they've given us f of x this time. They told us the function, x squared. Okay? We need 5 subintervals of equal, it says length, but they're supposed to be width. It's supposed to be width. So 5 subintervals of equal width. And they want an RAM. And they want an RAM. Okay. So you can make a table, or we can draw a picture. It's up to you. It is up to you. I'll draw a table. So we got x, and we got f of x. Start at 1. Okay, so before we start the table, how wide are each of the rectangles going to be? How do we know that? How do we figure out how wide they're each going to be? We need 5. And how much area, how much distance do those 5 need to cover? 2.5, yeah, from 1 to 3.5, 2.5. So we need them to cover 2.5 units, and we need 5 of them. So how wide are each of them going to be? Half, right, half. Each of them are going to be half. And we have RAM. So the way I did that was 5 rectangles, (2.5) distance interval. Your interval is 2.5 from 1 to 2.5. When you divide those, you get 0.5. So that's what each needs to be. And it's RAM. Okay? So next one's going to be 1.5, 2, 2.5, 3, 3.5. So the first rectangle is going to go from 1 to 1.5. The next rectangle is going to go from 1.5 to 2, from 2 to 2.5, from 2.5 to 3, and then from 3 to 3.5. That's 5 rectangles, and they're all 0.5 in width. So before we start calculating, or before we start adding numbers up, finding area, we need to find how tall they are. So how do I figure out these guys? Use the equation, right? The equation is just x squared. So whatever the x value is, just square it. 1 squared is 1. 1.5 squared, 15 times 15 is 225, so 2.25. 2 squared is 4. 25 times 25 is 625, so 2.5 squared is 6.25. 3 squared is 9. 3.5, let's see, 3.5 times 3.5, 17, 10, 2, 2, 12.25. Okay, so the area from 1 to 3.5 for x squared dx this is RM. So what side of the rectangle is going to determine the height? The right side. So the right side, I'll highlight in green or yellow the right side for each. First rectangle is going to have a width of 0.5, a height of 2.25. Second rectangle is going to have a width of 0.5, a height of 4. The next rectangle is going to have a width of 0.5 again, a height of 6.25. The next rectangle is going to have a width of 0.5 and a height of 9. And then the last rectangle is going to have a width of 0.5 and a height of 12.525. Okay. So half, so you just have to multiply by half. So half of 2.25 is 1.125, I believe. Half of 4 is 2. Half of 6.25 is 3.125. Half of 9 is 3. And half of 6, or 3, 4.5, sorry. Half of 9 is 4.5. And half of 12.25 is 6.125. So when I add up the 0.125s, I get 0.75, I believe. No. When I add up, let's see. Let me do this. Okay, so let me see if I add up this number and this number. I get 4.25. And then if I add up this number and this number, I get 6, and then 6.125. So I'm going to get 16.3. Was that? The 6 would be 6.5. 6.5. Which one? Say it again. Oh, 6.5. Yeah, you're right. No. Yep, the blues should be 6.5. Yeah. So that's, let's see here. So these two guys is going to be 10.75 plus 6.125, 16.875. Okay. Okay. All right. So last one. So I want you to do on the last one. The last, no, sorry. The last one is, sorry, we haven't done trapezoid. So we're going to do trapezoid now. Just because it's a trapezoid, it's not going to change anything. Okay? It's not just because it's a trapezoid, it's not going to change anything. The only thing it's going to change is at the very end when we do our calculations. We're still going to make a table. Still going to make a table. I still need to make a table. The trapezoids need to be equal length. So the trapezoids are going to look like this. So you're either going to have trapezoids that look like this, or you're going to have trapezoids that look like that. All the trapezoids are going to look like one of those two guys. So it has a width. So the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. Okay. The height is going to be the width. Base 1 is usually the shorter side. Base 2 is usually the longer side. But they're interchangeable. Base 1 and base 2 are interchangeable. You're just adding up the two sides. Okay. That's at the end, though. We're not going to worry about that until the end. First thing I need to do is figure out, first of all, how wide are each of them going to be? And I need to make my table. Okay? So, how wide is the interval for this guy? 4, right? From 2 to 6. How many intervals do I need? Or how many trapezoids do I need? 4. So it makes sense that each of them is how wide? One unit, right? Makes sense that each of them is 1 unit. Okay, so that meets my table. Let me go make my table. So if each of them is 1 unit, I can just go by ones. I'll draw a graph on this one since we haven't done root trapezoid. I'll do a graph with it. Usually you don't have to do both, a table and a graph, but I want to do both just to show you what it looks like. Okay. So how do I figure out 2? How do I figure out the height for 2? Plug it in, right? So when I plug it in, what is it going to be? 3, right? Because you're just plugging it into the bottom. So it's 6 divided by whatever x is. So this is going to be 3. When I plug in 3, it's going to be 6 divided by 3 this time, which is 2. The next one is 4. 6 divided by 4 is 1.5. 3 over 2 or 1.5. When I plug in 5, it's a little different. So when I plug in 5, it's going to be 1.2. Yeah, 1.2. When I plug in 6, 6 divided by 6 is just 1. Let me go make my graph. Okay, so 2, 3. 3, 2. 4, 1.5. 5, 1.2. 6, 1. Decreasing function. Now I'm going to draw each of those 4 trapezoids. Okay, so like I told you at the beginning, they're either going to look like this or like this, depending on what the function is doing. This guy's decreasing. So they're all going to look like this. All of the trapezoids are going to look like that. So the first base is going to be here. The second base is going to be here. And then you're going to connect them there. For the next one, the first base is there already. Second base is here. Connect them. And there are the trapezoids. We got 4 of them. Okay, so let's focus on the first trapezoid. I'm only focusing on the first trapezoid. This guy right here. Okay, base 1 is this length. Base 2 is this length. So we're going to add those two guys together. So the first one is 3 high. The second one is 2 high. So when we add them together, we get 5. We got 3 plus 2 divided by 2, right? And then what's the width of each of these guys? 1, right? There's the first one. I'll color code these guys so you guys can. The second one is this guy right here. The orange guy. Base 1 is 2. Base 3, or base 1 is 2. Base 2 is, I think it was 4.5? 1.5, yeah. So it's going to be 2 plus 1.5. Divided by 2 times the width, which is 1. Next one. So the next one is going to have base 1 is going to be 1.5. Base 2 is going to be 1.2, we said in the table. So 1.5 plus 1.2 divided by 2. Last one. Is this guy right here. So this guy is going to have base 1, 1.2. Base 2 is just 1. So 1.2 plus 1 divided by 2 times the width. Okay. We just need to do some math now. The first guy is, what is that, 5 over 2? So the first one's going to be 5 over 2, which is 2.5. Use a different color. 2.5 plus. The next guy is 3.5 divided by 2. What is 3.5 divided by 2? 1.75? Let's see. 3.5 divided by 2, 1.75. 1.75 plus, see, the pink one is 2.7 divided by 2. 2.7 divided by 2 is 1.35. And then the last one's 2.2 divided by 2, which is 1.1. So add them all together. We get 4.25 on top and 2.45 on the bottom. We get 6.7. 7 points. Was 6.7? Yeah. Yeah, double check my math, but I think that's right. Okay. So the only difference with a trapezoid is that you use a different formula. When you're calculating, you just use a different formula. Okay. I would suggest drawing pictures, especially for the trapezoids, because sometimes it's confusing. Okay, so base 1 and base 2, add those up. If you have a table, it's not that hard because both are going to be. So this is base 1, this is base 2. So this one's 3 high, and this one's 2 high, and then the width is 1. If you can do that in your head, do it. If you can't, draw a picture. Draw a picture to take your time to do that. Okay? All right. And that's it. Tomorrow, like I said, tomorrow I'll give you some practice. I'll give you your practice, and that's about it. Okay.